Okay, welcome back. Today we're going to be talking about the meaning of position versus time graphs. If you were to look at the first two graphs, what's happening? What's the car doing? Yeah.
It's stationary.
Why do you say it's stationary?
Because its speed is 0.
Its speed is 0. Yeah, you look at the number, it's like 0 meters per second. 0 meters per second. Is there another way to tell that the cars are stopped? There's no slope, right? Okay, so what I want you to do for these 6 graphs is I want you to answer these questions. Is this a graph of something stopped, moving slowly, or moving quickly? Also, is the car, if it is moving, is it moving forward or is it moving backward? All right, take a minute to do these 6 graphs, and you can talk with your partner on this. Tell me, stop, slow, fast, forward, or backward? Go. And also, for the last one, remember, you actually need to calculate that slope too. Okay, go ahead, turn to your neighbor. Check and see what they got. Okay, here we go. So, first graph, stop, slow, fast. Stopped. Second graph. Also stopped. What's the key? If something stopped, how many meters per second is it going? 0. What does the graph look like? Well, all of these have straight lines, but horizontal. Do you guys know horizontal and vertical? Horizontal, yeah. A constant or a horizontal line would be a stopped graph. All right, good. All right, let's take a look. Next one. This one right here, stop, slow, or fast? Well, actually, let's do forward or backward first. This one going forward or backward? Forward, good. And we know that because it starts at 0 and then increases in the positive direction, goes forward. All right. Next one right here, forward or backward? Forward. Which one's slow and which one's fast? The first one's slow. Second one is fast. That's right. And you can tell that from the slope, right? The steeper slope means faster. All right, last ones. Forward or backward? Backward. Which one's slow and which one's fast? All right. Does anyone know? First one's slow, second one's fast. All right, so let's take a look at these 4. Which ones are the slow ones? On the left, and the fast ones over here on the right. All right, and you can look, you can tell based on the slope. All right, so everybody with your arms, I want you to hold up a stop. What does it look like when the cars stop? What's the graph going to look like? Show me with your arm. Okay, good. Everybody's holding their arm level. Show me a fast forward. All right. Show me fast backward. Right? What's slow forward look like? Like that, and slow backward. All right, good. That's it. Okay, page that says average versus instantaneous velocity. A few pages down in your notes. All right, so before we start looking at actual numbers, I'm going to point to a section of the graph, and I want you to tell me whether it's stopped, slow, fast, forward, or backward. All right, ready? Here we go. First one, this section right here. Stopped. This section. Backward, slow. This section. Backward, fast. Stopped. Forward, fast. Stopped. Backward, medium, maybe? I don't know. Got it? All right. So what we can actually do is, if I give you a time interval, you can calculate the average velocity even if it's speeding up and slowing down along the way. And the way to do that is really simple. For example, this first chunk of time from here to here, that's from 0 to 2 seconds. What's the velocity? 0, right? How do you know that? It's horizontal line. Fine. All right, so I'm just going to write that in. That's 0 meters per second. If you had to compute it, how would you compute it? How do you do a slope? You've got 2 points, right? Meters minus meters divided by seconds minus seconds. So I'm actually going to do that right here. I've got 4 meters minus 4 meters divided by 2 seconds minus 0 seconds. 0 minus 2 is, 0 divided by 2 is 0. Good? So that's fine when it's just a short little piece like this, but what about from 0 to 4 seconds? Well, let's do that same thing. I'm going to do different color. I'm going to circle this spot and this spot again. All right, so here we go. I've got 2 meters minus 4 meters over 4 seconds minus 0 seconds. Let's see. That's negative 2 meters over 4 seconds. So what's the average velocity? Negative 0.5 meters per second. All right. Go ahead, working together with your partner, do the rest of these average velocities. Okay, once you've got them all, check with your neighbor. Make sure you agree. Take a few minutes. All right. That should be okay. So what you figured out is basically anytime you have a really squiggly, screwy, piecewise graph like this, it's really easy to do an average velocity over the whole thing because you don't actually care what happens in the middle. You just take the start point and the end point and do a slope from there to there and you're done. All right? Does that make sense? So the average, what do you guys get for the whole thing, average velocity? It's 0, right? Because if you think about it, from here to here on average, there was 0 velocity. Partially negative, partially positive, it averages out to 0. All right. Now, what if I were to ask you a slightly different question? I want to know, because we know velocity can change, what is the velocity right here at this point right here at 1 second? How fast is the car going? 0. How did you do that? Yeah. Yeah, you looked at that and you're like, oh, that's a horizontal line. But I also can look at the endpoints and I know that the velocity, because this is a straight line, I know the velocity everywhere along here is all 0, right? But what about right here at 3 seconds? What's the car doing, forward or backward? Backward, so that should be a negative velocity. Is it possible to figure out the instantaneous velocity at 3 seconds somehow? How would you do it? If I just want to know at 3 seconds, well, it's a straight line, right? So all I really have to do is figure out the velocity from 2 to 4 seconds, and that's the velocity at 3. Right? So that's what we're going to do. It's called instantaneous velocity, or velocity at this particular instant. All right, so here we go. Scroll down a little bit. At 1 second, what's the velocity? 0, right. Okay, so I'm just going to write that one in. So velocity is 0 meters per second. What's the speed? If velocity is 0, how fast is it going? 0. Good. So those are both 0. That's fine. All right. That one's too easy. Let's do at 3 seconds. So I'm talking about this point right here. 3 seconds. To do the velocity there, I got to use the endpoints of the segments it's on. So 2 meters minus 4 meters divided by 4 seconds minus 2 seconds. All right, so here we go. Let's write that in. All right. 2 meters minus 4 meters over 4 seconds minus 2 seconds should give me negative 1 meter per second. Got it? There's my negative velocity. Well, what about speed? How fast is it going? Yeah. 1 meter per second. Good. All right, go ahead and finish it up the rest of the velocity, the instantaneous velocities and speeds. Take a few minutes. All right, take a look at mine. Make sure they match. Any questions? What do you notice about speeds? They're never negative, right? It's just the absolute value of whatever the velocity is. Yes? No, I just did that to be explicit, but no, if you just want to write 6, it's fine. All right, any other questions? Okay, that's it. Nice work.